Try and be efficient. Guys, couple things. I will be handing back the tests that you took on Monday and quiz corrections that you guys turned in. And we need to talk about inverses on Wednesday next week. You're going to have a test on all the things that we've done so far. So that might be domain and range, being able to do this thing, which is find the inverse of something. You did something like this in Algebra 2. Do you guys remember what an inverse is?
Like, don't look back at me.
Okay. So how to undo something? It would exactly say opposite, but it's like on the computer when you Control Z, undo, right? That's inverse. All right. So we need to be able to undo things. Let's see.
No one's going for me much. Guys.
I'm sorry.
Sorry,
Handing
no, I
everything
got
back.
confused. Sorry.
Excuse me. Okay.
What was it even? 18. This one's 15.
This is like the one we said last time.
The most recent one, right?
Yeah.
Oh, it's called 18 points.
Oh no.
Oh.
All right.
Or maybe you already
so-
got that one back.
Some of my corrections were kind of.
Inverse operations. Okay, an inverse function. Any idea? Anything about inverse functions? Jean Gideon?
Functions like, in other words, like just doing a certain portion, like.
Guys, ladies, stop.
Sorry.
Sorry, say again?
It's like doing, it's undoing like certain functions,
So what would be the undo of the function x plus 3?
like x minus 3,
X minus 3. What would undo x times 2?
x divided by 2.
X divided by 2. So inverse functions, they undo the operation. So if okay, do you guys remember this notation, f to the minus 1, that means inverse? This should not be unfamiliar. So to do those composite things from yesterday, f of f inverse, okay, up here f inverse is x over 2. F of that, if I multiply by 2 and then divide by 2, I get the same stupid number back, right? Like, that's the reason that we have these undo functions. Sometimes it's important to be able to do that Control Z. Can you Control Z everything, or are there some operations you can't undo? Like, how do you uncrack an egg? There's some things that you cannot undo. And there are some things when you do square root, you need to remember it's plus or minus 5. But if I say square root itself, it is just the positive 5. So there's some things we're going to have to make some restrictions on. So this is just a heads up of what's coming. So, can you guys, hello, do those two problems? Given this f of x and that g of x, can you find f of g and g of f? Use training to see the board, I will have you see next week.
It's like we're waiting so bad for Marcy.
Oh.
Let's go. I'll be stuck in those buttons.
Yes.
Well, yeah, but they're updating, so I can still see. They're like updated prescriptions. I thought it was too late. So I thought you were probably right.
Yesterday's homework I didn't actually put in the grade, but it's from 2 days ago. Okay, that's good.
Just like honestly, like that's like whatever you get, like minus it by like 5. Me too. No, minus it by 4. So
I thought that's all
oh, it is. Oh,
Yes, that could do
this
one
one
more
was
than
yeah,
four.
so I got actually make sure. Let me make sure my eyes aren't deceiving me. My eyes are definitely not deceiving me. You should honestly, you should just guess and I'll tell you what my fires lower, much lower. Go, keep going. Yeah.
That's weird.
Guys, it's looking like I'm not graduating.
I'm still graduating.
Guys, I don't know if I should laugh or cry.
It's okay.
Y'all.
That's
Yeah, I'm really holding me laugh right now, so take it away.
no, I just like 50. I keep on forgetting 50%.
Wait, so. Oh, let's go. So, yeah, got way less than that. Way less than that. So, let's keep it
More and more clear.
Oh, that? I'm trying to figure that out. 'Cause amazing this kind of
The X. No.
like it's like just do the same thing we always do.
Yeah, right? I don't know why, I always think we self-shit by
Okay, so I'm actually hearing a lot of math conversation, that's good. Can we look at the problem though and not look at the test at the moment? We have questions about the test, hopefully we can put some time in at the end. But f of g of x. Distributing, I get x plus 4 minus 4, and that ends up being x. Dylan, how do I do the other one? G of f of x. What is f of x?
Either g of 2x minus 4 equals 1/2 times 2x minus 4 plus 2.
You said the right thing, I wrote the wrong thing. Hold on. You said 1/2 2x minus 4, close the parentheses, and then plus 2. Leah, when I distribute the 1/2, what do I get?
You get 1x and -2.
And then what do I do with
And
this?
then +2.
And the plus 2's there. So I get x on both of them. What do you think that means about these functions?
Your domain is the same.
Doesn't mean their domain has to be the same, Tim.
One of them is the inverse of the other.
They're the inverse of the other. So like add 3 and subtract 3, like multiply by 2, divide by 2. Evidently, multiplying by 2 and subtracting 4, the undo, the inverse of that is half of x plus 2. Why do we know that? Well, when I applied both operations, do this stuff, undo this stuff, I got x out on both sides. That means they are inverses. So, a heads up, if there's a question on the test that says, prove they are inverses, you need to find this, and they better both be x. Okay, this one's harder because you guys don't like cubes. Try those two.
Yeah, it's just like the light.
Does this help?
Oh, yeah.
Yes.
I didn't, yeah, I didn't, I just took out the time. Right. Because then there's also like, I wouldn't go for negative 6 or 10. Oh. I don't know.
I'm pretty sure they're meant to be. I guess there's no, there's just a cube plus.
Yeah, I'm confused, because, like, the square, like, the shape, I don't know if that goes over.
It cancels out because if you're, alright,
The opposite.
so the first one is square, it's a cube, and then it's cube, it cancels out the cube.
Yeah, but like, does it go over like this one, like you see this?
Yeah. Including the six and also
So would it just be like x plus, or just x? Okay.
Not sure if you need to make the cube a square root. Okay, so f of g of x. Kevin, what do I put in for g of x?
Yeah, you put x to the cube, parentheses, 3 root x plus 6, and then
Okay.
parentheses and 6.
Okay, so this little check mark with the 3 in there, that means to the 1/3 power, okay? Are you guys all right with Algebra 2 supposedly spent forever on being able to translate back and forth from these? Judging by what my calculus kids do, they will not let it go. I hate the little check mark thing, and I always want it as a fraction exponent. So I gotta break those habits. I'm certain it comes from Algebra 2. Okay, so f of g of x, I'm rewriting g of x because I don't like the check mark. And now f of stuff is stuff to the 3rd plus 6. Boaz, what is stuff in this case? X minus 6 to the 1/3. Fakir, how do I raise a power to a power? So what is 1/3 times 3? 3. Well, 1/3 times 3.
Like,
I have 3 cookies to share among 3 people.
so 1.
So 1. So this is x minus 6 to the 1st power. Do I need to write parentheses to the 1st power? Spencer, what is x minus 6 to the 1st? do I need to keep the parentheses into the first, or can I just let it, I can just let it go? And this plus 6 comes down, so I get x. Ally, how do I do the g of f of x?
You do g and then parentheses x to the third plus 6 equals in the third square root x to the third plus 6 minus 6.
And Noah, what is x to the third to the 1/3? X to the 3 to the 1/3. Okay, raising a power to a power, what do I do with the exponent? Multiply. So what is 3 times 1/3? She just answered it a minute ago. X. Period. You could say x to the first, but it's x. Huh? Yep.
If you, like, so you just proved their inverse functions, right?
Yep.
If you had the same thing, but it was like 2x and you, like, and they both ended up at like 2x plus 1 or something, would they be inverse?
They're not inverses unless they both come out to just x, because that's what inverses are. I put something in and, oh no, I didn't want to do that, Control Z. I better get exactly the same thing out, or it's not an inverse. If it's like, hit Control Z, but it's now bolded and in Arial font instead of regular Times New Roman, that's bad. So it's gotta be exactly the same thing comes out. Yes?
So it could be like x plus 6 for both. As long as it's the same, it's fine. Or does it have to always just be x?
It has to just be x. It's not, and I don't know that it could ever come out, oh, both of them are gonna spit out x plus 6 or something. I don't think that's possible. Okay, so, we got x's on both of those kinds of things, so they were inverses. All right, can you guys do these two? And it may or may not be inverses, there is definitely a catch to this one, which is part of the conversation we need to have. Sorry, those friends in the back. A little bit better?
What is the x's gradient?
Okay. Tess is picking up on one of the things that I was like, Tell you in a second. Cameron, are you done? Cameron, if you're not done, the pencil should be moving, not the mouth. Got a question? Okay, so Leah's like, how do you do it? Like, there's issues, we can't do some of these things. Well, first, let's just blindly do what we've been doing. F of G. Well, F is square root of stuff. And I kind of get X. but technically, the square root was there, it's always gonna be positive, and sometimes x might have been negative. Which is, Tessa picked up on, why does it say that? Again, I'll get to it. G of f of x sorry, it's gone. So I get x out of this one as well, but let's look at the graph. Ooh. So x squared plus 3, the problem itself said only for places x greater than or equal to 0. So that's really what the graph looks like. Inverses graphically, do you guys know what they are supposed to do? No? Inverses graphically fold over the line y equals x. Does it look like if I took this line and folded it over the green line, do I get that other side? Yeah? Are they both functions? Is this little swoop a function and is that one? Some of you are saying yes. Naomi, why is this yes in fact a function? What are we looking at? The y values. For every x that I have, there can only be one y value. Now, if I take that guy and flip it over, is that green thing now a function? Is that guy a function? No. So we're going to have issues that we need to deal with inverses that we're going to have to restrict some domains from the original to make this thing still be a function. You do have homework tonight. It is on delta math. And we will do more inverses and restricting their domain on Monday. Tuesday will be a review. Wednesday is a test. Right? That's it on there. Yeah.